Hello, everyone. Thanks for joining the webinar today. I realize we're just a couple of minutes over, but I'm gonna give it just one more minute maybe for everyone to join in, and we'll get started. Maybe even less than a minute. Yes, Melin, the session will be recorded. And yeah, you will also get the recording afterwards. Cool. I think I see enough people have joined. I think people can join in through the session as well. So welcome everyone to another webinar. Today we're talking about the 5 steps for a successful generative AI pilot. And we have today with us Mathis. Mathis is the VP of product here at deepset, who's going to guide us through all of these critical steps. So Mathis, I'm going to not take up any more time and hand it over to you straight away. Just one word for the audience here. We are going to use the Q&A section. So if you have any questions during the session, please drop it in there. And yeah, have a nice webinar about this.
Thanks, Pari, and hi everyone. Glad to be here today. Let me just share my screen, and then we can get right into it. So today I'm talking about how to run a successful Gen AI pilot. And I'm very sure that the topic is top of mind for a lot of people because 2023 was actually an incredible year for AI. Like every company on the planet started to think about AI. Many launched AI projects, and we all got almost a little drunk on the ChatGPT hype. But this year, it's actually time to get sober because we still don't see many AI applications in production, and people are realizing that building a production-ready AI system is actually hard. So that's why I'm going to share 5 steps to cure the hangover and to get your AI initiatives off the ground. And I want to start with step 1. Identify your use case. A use case means that you can define what you will be using AI for and how it brings measurable value to your business. So how do you go about finding one? Well, you need to get your business people and your data science people, your technical people into a room. And this is where many make the first mistake because they go to their data science team instead and they ask them, hey, what are the use cases for large language models that you see? And the problem here is that the data science people are too far away from your business problems. They might not know anything about them. And your business people, on the other hand, they know the business problems. They're working with them day in and day out, but they might not know anything about the technical side. And that's why you need to get both of them into a room and have them communicate, have them talk through a few different business problems and what's possible with the technology. And now that you got everyone in a room, and maybe they brainstormed a long list of use cases, and for every single one of these use cases, it needs to be crystal clear what tangible business value it is delivering. Like that needs to be understood by everyone in the room. And now that you have that long list of business cases, you need to prioritize it. And your prioritization needs to be guided by two questions. The first one is, how valuable would it be if this problem was solved? And the second one is, how much effort is it going to be to solve it? And now I'm not going to tell you how to measure value, because I'm not in your business and you probably know best. But I can share a couple of simple tricks to nail the effort part of this equation. Because there's a few traps kind of that you can fall into, and a few techniques to directly from the start weed out the use case that you don't want to do because it might not be so feasible. The first one is, have you got the data? So most AI systems operate on some kind of data, and you should ask yourself, do I have access to the data? Am I allowed to use the data? And is the data in the right format? If you have to scrape the data off the internet, or it's living in 100 different places and you never really manage to reconcile it, then you don't have the data. And don't pick a use case when you don't have the data. That's a bad idea, especially for a first use case. The second trap that you might fall into is what I call AI maximalism. And now, what do I mean by that? What I mean is that pretty often when people come to AI, they have kind of exaggerated expectations. And AI does not have to replace an entire workflow. There's often value if you're only solving a small part of an existing workflow. Take a salesperson, for example. Their dream might be an AI that finds the right prospects for them, that generates an email and reaches out to them, that calls them automatically, and then follows up with an auto-generated and customized demo video. Like, how cool would that be? But this is simply too much when you're starting out. And just like a better search for prospecting would probably already get you incredible efficiency gains across your entire sales organization. So the lesson here is, like, don't try to start too big, start small. And that means that on this graph here, I want you to put all your use cases on this kind of chart. Like on one axis, you have the value, and on the other one, you have the effort. And looking at that chart, you want to pick the use case that maximizes value and minimizes effort. And as a rough guideline, what we see with many of our clients is that it shouldn't take you more than 4 weeks to get to a realistic prototype. So if you kind of use your technical people and you talk through and you estimate effort and you're like, okay, 4 weeks, this is realistic in 4 weeks as a prototype. And I'm going to talk about what a real prototype means later. But as a prototype, 4 weeks is realistic. Then you should pick the use case with maximum value in that range. All right. So you have a great use case. Let's go and take step 2. Step 2 is assemble your team. You always need a team to tackle a project. And I'm going to share the most important roles that we see in most successful teams. The first one is the product leader. You need someone who will lead the whole thing, someone who will talk to stakeholders, who establishes the product vision, who keeps delivery on track. And pretty much what we see is that a strong product leader is the best predictor for a successful Gen AI pilot. Second one is the AI engineer. The AI engineer is a systems thinker who understands the current AI landscape, who knows how to apply technologies like large language models, vector DBs, embedding retrieval, who has prompt engineering skills. And most importantly, they also need a strong product mindset. So if you're looking around in your organization, like who's the right AI engineering team? Who do I want to pick? Pick people who have actually shipped real applications to end users, who have delivered value before. That can be a data scientist, but it can also be a software engineer, a product engineer who has a knack for AI and upskilled in that area. The third one is the domain expert. Traditional software pretty much creates the structure that your user operates in. And AI software actually operates on the content that your users are operating onto. And because you are operating on the content, you need someone with domain expertise, someone who can test the application, someone who can work with the AI engineer and the product manager during the development phase and make sure that from a content perspective, this application is going into the right direction. Any team where you have kind of a dedicated domain expert, subject matter expert, it's going to move faster than one where you always have to fish somewhere for that expertise. And then apart from these three, you might need other roles. Those can be a backend engineer, a front-end engineer, a UI UX designer, a DevOps engineer, a data engineer. That really depends on like, are you building an internal workflow tool that doesn't have a UI? You probably don't need the front-end engineer in that case. Are you building on an existing AI platform that abstracts away the deployment needs and the infrastructure? You might not need a DevOps engineer. So this is really dependent on your project. All right. We have the team in place and we have a great use case. So let's go and take step 3. Step 3 is mapping the use case to the technology. This is where you need to make a plan, basically. You need to decide what is your system going to do? What are the components that you need? And what I want you to do is basically think about the end user of your application and think about what do they put into the system and what is the expected output. And write that down, like input and output. And now what you need to decide is what's happening in between input and output. That's going to be roughly your technical architecture. And to find out what should be there, what should be between input and output, I want to briefly talk about 3 concepts with LLMs that come up. They're not really large language model exclusive. It's some of them are more small language models, but they are important concepts and a rough guideline that can help you decide what components you want to use. So I want to talk about search, about content generation, and about decision making. If you're using data, you will probably need a search component. Search is any system that takes a user query, a question, and finds the most relevant data points for that question. Search can be a simple keyword search, or it can be a more sophisticated semantic search system that relies on vector embeddings. That's really up to your application. The next one, content generation, is whenever your model generates novel content. Let's take an AI model that generates a sales email, sales outreach email. That's content generation. And then decision making is pretty interesting. That's when your system or your model decides to go down one path or the other. And a simple version of decision making is classification. Let's say you have a model that can decide if a customer that's calling is angry or if it's a happy customer. And then the angry customers might be routed to a priority queue somewhere, and the happy customers have to wait a little longer. So that's a decision-making component. With large language models, there are more complex kinds of decision-making, almost reasoning that you can do. But I'm not going too deep into that right now because it's more about the concepts than how it's actually working in the end. And now what you do, pretty much between your map of expected user inputs and expected outputs, you put these different components. And what you see here on this slide is essentially a RAG application. You have a search component that retrieves data from a data store. You have the decision-making component, which decides, is this relevant or not? And then you have the generative component that generates an answer. What we do with our clients in practice to accelerate this, because there are tons of different application architectures that you can use, we have a set of architecture templates, let's say RAG, semantic search, chat, and we kind of go in and compare these architecture templates with their use case, with their inputs and outputs to arrive at the desired architecture faster. And usually what we have is a mix of these different components. Like, you never have just the model. What we are talking about when we are building these more complex systems, we're actually talking about compound AI systems. So a whole system that achieves mapping inputs to outputs, not just the model. All right. We have a great use case. We have a stellar team, and we've mapped our use case to the technology. We know our rough architecture. Let's take step 4. Start building. Step 4, really, there's not much to say about it. It's about rolling up your sleeves, getting heads down into coding mode, building mode, delivering mode. Your goal is to build a prototype and to build it as fast as possible. There are a few things that you need to pay attention to. The first one is, it's important that you don't get lost in the details. You shouldn't optimize for scale at this stage. It's very likely that your production system needs to scale incredibly well. It might need to support hundreds of thousands of users. You might need to introduce cost reductions, but that's not the question right now. You optimize for speed of delivery. You want to get your prototype out as fast as possible. And at the same time, and this is now going to sound like I'm contradicting myself, at the same time, you need to build a prototype that's production grade. And what do I mean by a production grade prototype? What I mean is that it needs to operate on the actual data that you will use in production. It needs to be interactive, so the user can ask a question and get an answer, or whatever other system you're building. And it needs to be already valuable to your user. So if you're trying to prove out a search a RAG application, it can't be on a single file, because as a user, I can just read that file. It actually needs to be on a meaningful set of data, something that I want to use. Everything else, like, that doesn't meet these criteria of a production grade prototype, everything else is just a demo. If you spin up your laptop, you just show something as a presentation, that's not a prototype. As a rough guideline, it should take you between 1 and 4 weeks to deliver your first prototype. That's roughly what we see our clients delivering, and it's roughly the time you want to spend in this stage, because you haven't validated any of your ideas. You don't want to throw away a lot of time and effort because you work too long on an idea that isn't validated. All right. We have use case, great team, our architecture. We build a realistic prototype, and now it's time to test the application. This is when it gets real, because you're shipping your prototype to actual users. And what they should do is they should use it and give feedback. And what we usually advise to do is, when you start out, like, you ship the first iteration, test it with 5 to 10 users, do a couple of small fixes, and then roll it out to a few hundred users, if that's an external application. For internal applications, often you might only have like 50 or 60 users, so then just roll it out to all of them. And during that testing phase, it's really important that you record all the inputs and the outputs to the system, save them, allow the users to give feedback on the prototype, and you can also take other measures to gather insights from your users. So because what you're really doing is you're trying to validate your value hypothesis. Is this something that my users want to use? Does this work? Does it produce the right results? And to give you a rough idea about how this testing phase could look like, I want to talk about one of our customers in the legal space, and they are building a generative AI chatbot for lawyers. And what they did, basically, they built a prototype. Initially, they tested with 5 legal professionals, like real lawyers, collected feedback, made a few fixes, and then they rolled it out to about 1,000 of their actual customers and tested again. And they captured all the interactions, like everything going in and out. And then they even sent out a survey after the test. So everyone who participated in the prototype testing got a survey afterwards. And a result from that survey was that 85% of the surveyed users said that they would definitely use this product if it was available. And on top of that, the customer had identified a few remaining issues that they need to solve before going to production. So if you think about that, that's really great, because they built this prototype for 4 weeks. They tested it. They validated their entire product idea. They have real data, real insights, not some artificial benchmark. They know that their users want this. They would pay for this. And they also have right in front of them, this, and that is what I need to fix before going to production. And that's really the most valuable signal you can get. As an indicator, when your users in the prototype testing phase, if they come back to the prototype, meaning that they use it the first day, they come back the second day and use it again, they come back the third day and use it again, you know that you have a product that is sticky. You have identified something that they need, they see value in it. And that's where you want to get. And to get there, basically it's a cycle of like test, improve, test. That's what should drive your entire product development. All right, let's recap. We found our use case. We got the technical people and the business people into a room. We brainstormed a long list of use cases. We prioritized value versus effort, and we picked one that has measurable business value. We assembled our team, product leader, AI engineer, domain expert, a few software engineers. We mapped the use case to the technology. We drew our rough system architecture. We decided, is this RAG? Is this semantic search? Is this a chatbot? We built a prototype. For that, we moved fast. We built something realistic, interactive. And we tested the prototype. We validated the idea. We collected feedback, and we iterated on the results. And that's it. That's all you need. That's everything you need for successful generative AI pilot. And sounds simple, but in reality, it can be incredibly hard to align everyone on this. But if you follow this fast iteration, fast cycles, you will be more successful. All right. That's everything I have to tell you right now, and now I'm happy to answer any questions that you might have.
Awesome. Yeah, we have a couple of questions already on the board, Mathis. So I'm just gonna read out like the latest one here. So Sid put in a very interesting question, I think worthy of a discussion. So he's saying, where in the process should we be extra careful because we're dealing with generative AI? Now, one can argue that all of these steps apply when launching any new tech, whether it's Gen AI or not. But he's curious to know if there's like one or two more like steps where we need to be like really, really careful in this particular context. Like,
yeah. So I think right from the start, when you pick your use case and then you think about your rough architecture, think about what's at stake with your use case. Like, is it an internal application where it's assisting someone in their existing workflow and they cross-check everything that the generative AI produces? You might not need that many security controls. If you already know this is a high-risk system that needs to be right, or it needs to have strong controls, plan for that in your rough architecture. Like, plan for that security layer. Like, let's say we have a webinar, for example, where we talk about prompt injections, external users trying to hijack your application, like we've seen over the past few weeks with like, I think a Chevy sales chatbot or an airline support agent. So if people are trying to hijack that, add a control there so that it doesn't happen. Or on the output level, you need a lot of trust in the groundedness of your answer. You don't want to have any hallucinations, for example. Then plan for that component in your architecture. And for the actual prototype testing, also look at what's at stake here. If you're testing it internally, we like to just roll it out without the security controls, for example, and then actually go ahead and have a a specific red teaming phase where we try to break the application, where we try to hijack it, where we try to get unwanted responses. So test kind of the security aspect then maybe after validating the first idea and doubling down later.
Got it. I think a lot of questions have popped up now. I'm trying to try to get through all of them. So the one has been around for a while. So the question is there an agent framework available for architecture to do mapping between inputs and outputs to get the desired results from LLMs?
Yeah, so there's definitely a couple of frameworks. What we have, for example, is our open source Haystack framework. And when you're talking about agents, what we're seeing is actually the more structure you give them, the better they perform. So let's take the LLM should make some decision, but there are only really 5 decisions it can take at this moment. Put that into some sort of pipeline logic so that it doesn't make a decision which it isn't allowed to do right now, for example. And in that way, one interesting aspect is, for example, I don't know, extracting structured information from unstructured documents. You can use a Haystack pipeline to do that. But that's just one example.
Got it. A couple of questions also came in through the chat now. So, like, what specific technical criteria do you use to move from a prototype to a production grade Gen AI solution?
A couple of different criteria. So first you have I would call them the table stakes. What's the expected response time of your application? How many users are you expecting? Will it scale to this amount of users? Like, can it handle 1,000 requests a minute, for example, or a day, or whatever your parameters are? Do you have all the security controls in place? Do you have that trust layer to make sure your model is not hallucinating? Do you have the input side protection from a prompt injection model, for example? So these are kind of table stakes, and then it's really about what is the minimal like performance that you need to have a valuable use case. We often see, so unexpectedly, for example, what we often see is when people give feedback, we kind of get like 60-65% positive feedback from a large group of users. When you actually go and ask them directly, like, how are you liking our application? Everyone is like, wow, it's so great. It just works and it's so cool. We're like, okay, but it's only 65% positive. The reality is like feedback always skews negative. So people are more likely to give negative feedback than positive feedback. So that's why this is actually already a good number. So really think about these performance indicators and think about what do you need from that application to be valuable from a performance standpoint.
Got it. There's a couple more questions now around like a pilot to a prototype, right? So, oh, sorry, no, we picked that one just now. So it's like, Gal is asking, can you please share some of the most useful feedback questions that can be used from early pilot users? Okay.
So what we like to do is we have the implicit feedback, meaning how much is your application used? If you give a prototype to 10 people and like they use it once and never again, not a good sign. Or you give it to 10 people and only one uses it, maybe not a good time. Maybe they didn't have time. You need to make sure that they also have time. But look at the patterns, like do people come back to the application? Look at the feedback they give, like via thumbs up, thumbs down, or something like that. And then for asking, we like to do on a smaller scale, we like to do user interviews. So like really have an interview guide, ask them, how did you use this prototype? Could you show me? What do you think about this, that? Usually you have a few things that you're unsure about maybe, and that's what you want to ask, and ask that. And then for actual surveys, it's usually also good to just ask, would you use this if it was a product? It's also interesting to ask people if they would pay for it. Many people would use something if it was free, but when you ask them to pay for it, they're like, oh no, it's not that good, it's not that valuable. So that's a good test. Yeah.
Yeah, awesome. Then there's a couple of questions around like a prototype and and a product, you know. So where would you draw the line between an MVP and a prototype?
It's the I don't like, but it has nothing to do with AI. I don't like the term MVP. I think it's a bit overdone in general product management. But basically for this case, the difference is maybe your prototype needs to deliver the functionality. So people need to be able to interact with your AI feature or workflow. It doesn't have to be fully integrated into your product or have all the live data or be in a pretty UI, for example. So that's maybe the difference, where a prototype can be pretty raw, but it still delivers the essential functionality. And then if you're building the MVP, it's actually the first version you ship as part of your product. Yeah.
Yeah. Now there's a question around observability now in the Q&A section. So someone anonymous is saying, like, can you recommend any LLM observability tools before sharing the tool with like beta testers?
Yeah. So what we usually do is we run experiments in our platform in deepset Cloud. You can upload both either labeled data sets or unlabeled data sets, basically just the queries, and then run a few different architectures against these queries or data sets and see a few performance benchmarks, like let's say for the retrieval part, the search part of a RAG application, you see things like recall. Does it find the right data? For your large language model, I really recommend groundedness. If you want to learn more, you can go to our blog. We have a blog post about groundedness. It's showing you how much your large language model bases the answer in the documents that you have retrieved. Like, does it actually use your data to answer, or does it make something up? That's a good metric you want to have. We have that as an observability tool as well on the live traffic. And then there's a lot of value in also just interacting with your system and trying it out from a qualitative standpoint. So any like prompt studio, prompt thing, playground, where you as an AI engineer, for example, can interact with it, test a few different things, usually gives you a good idea about the performance of your system as well.
Another question we are getting is like, what would be the cost impact of implementing all of these steps? You know, there's a lot of things involved in there.
The what?
The cost impact, the cost of actually following on building through all of these critical steps.
Yeah, so as I said, like the actual prototype building should take between 1 and 4 weeks, depending how big your testing sample is. You will probably run it for 2 to 6 weeks, maybe for the testing phase or multiple testing phases. So let's say all in all, like 6 to 12 weeks for the whole project. You have a little bit of identifying the use case. We usually run workshops for that where it's like 1 or 2 days and you have a very good idea what would be a valuable use case and already also the technical architecture that you want to use. And then it really depends. We can deploy such a prototype in a matter of a few hours. To really dig deeper, I would still take a week. And then, yeah, the costs, mainly infrastructure costs, shouldn't be so much. And then it's mainly how many people are working on this.
Got it. So Daniel had a question here in the chat section. So is there a specific sizing guide to build the system when it comes to serving this either through a web application or through APIs?
It really depends on your use case. So data-wise, let's say it needs to fit your data. Pick a vector DB or storage size that where you can store all your data. And then in terms of like the maybe scalability of your, let's say, query pipeline, it should sustain probably like a dozen users for a start. And then if you roll out to 100 or 200, it should be able to handle that traffic. But it's very difficult to give specific sizing recommendations because basically it's very dependent on the pipeline. A GPT-4 enabled RAG application takes way longer than something where you have GPT 3.5. So different sizing requirements just because the latency is higher. And that's also why we have like this elastic scaling in our platform, because every use case is different in the end.
Got it. Oh wow, more questions, but okay, Jonathan had a question over here. It's like, how might we address test automation, solving for reliability over time for a non-deterministic output like LLMs?
Yeah, so you can run the tests beforehand, and then you can run a lot of, especially like model-based evaluation metrics on your live traffic. And that's how you check if everything is all right. And then you also should continuously collect user feedback, implicit and explicit. Like if you have a search, are people actually clicking on what you surfaced as a result? But also, are people giving positive or negative feedback explicitly to quickly detect like, okay, something seems to be off.
Got it. Now, Carl put up a interesting question, like considering data privacy, what methods or techniques do you use to ensure that a fine-tuned or trained foundational model is not leaking any confidential data? Are there ways of detecting this during testing or something?
Yeah, so generally, a model leaking data is only a concern for these generative models because they actually can spit out the data again. And that is it. I think it brings me more to the question of do you train your generative model? So what we see as a better pattern usually is to have a RAG pattern where you retrieve your data and LLM just generates the answer. So it's never trained on that data, so it can't leak any data because the performance gains you get, especially when you're comparing to the large commercial models, from fine-tuning on your data aren't actually that great usually. If it makes sense for your use case, you should clean your data from any confidential data beforehand. And that depends on your data. It could be a named entity recognition that you run over it, but it might be more involved where you actually need to review manually because, I don't know, there's like business secrets in there. So yeah, if you need to fine tune, then clean your data.
Got it. Now, Sid asked a question in the Q&A section again. So how should one think of build versus buy decisions, which is very interesting. We've seen our customers often lean towards build, but they can only take it so far as a prototype and they cannot scale it after that. So I'm curious to know, like, your thoughts, Mathis, on how a company should think about buying and building.
Yeah, I mean, we are a vendor of an AI platform, but I would have the same reply if I wasn't. What we see is basically for build, and I know that because I've been through it with my team. Essentially, we've built that platform for the past 2 years, and it's a considerable amount of effort, people, time, money that goes into it. So you really need to decide, is that what we want? And should you focus on building out the basic infrastructure? I like to compare it to the early cloud days where, especially bigger companies, where like we build our own cloud and they put tons of resources in building their own cloud. And what they should do instead, arguably, is focus on their business domain and really do the heavy lifting where they have expertise and not this like undifferentiated heavy lifting on basic infrastructure. The same applies for AI, I would say. I've heard recently of a case in a large bank where I can't name them, but they had their first use case, their first generative AI pilot. They built it out with over 80 people. Wow. Over 80 people for like half a year or something. I think typically we have 2 or 3 people working with our platform, and they get to results much faster than in half a year.
Yeah. Awesome. We have a couple of questions from Ahmed Gemma. So I'm going to read both of them out to you. Like, so technically speaking, this on the prototype versus MVP discussion, I think, isn't the code of the prototype reusable for the actual product? And the other one was, are we seeing a surge in the use of open source models, and are they mature enough for a production grade application?
Yeah, so regarding the code question, that's actually pretty interesting and a pretty good point. Usually you say something is a prototype, but you never throw it away and it becomes your production system. True. That's also why in deepset cloud, there's no distinction between prototype and production. It's just can seamlessly go from one to the other. If you're building your own code base, I would still advise not to spend too much time on premature optimization, because this might mean that you try and build out this great system that will be great for production, but then you realize AI is very new, you haven't tested this, you realize, oh fuck, it's actually not something that my users will use. So that's unfortunate then, and you wasted a lot of time. So think about that.
And how do you feel about the open source models? Do we see a surge? Do you think they're mature enough for production?
Yeah, we definitely see a surge. Let me put it this way: it's easier to use the commercial models. You will be faster, and I would do that for the first iteration if you can. But then you can make an open source model work and they are mature enough, some of them. Especially the Mistral models are quite good, but they need more tweaking, basically, than OpenAI's models, for example.
Got it. The last question I think here was, how would you analyze the user-bot interaction data qualitatively in an app which utilizes Gen AI for conversations? Would you do that for a pilot insight? And how much does that weigh versus like direct feedback for you?
Yes, I would definitely review them. In our product, we see the feedback like quantitatively, but you can dig into every single data point, and it tells you a lot, because sometimes the feedback might be negative, but actually they asked about something that's not in your database, for example, or the feedback might also be wrong, and you really get a better feel, especially if you sit down with a domain expert and you sit down with them and look at the data. You get a very good feel for what are failure patterns, like, because if it's language, as humans, we are incredibly good at seeing patterns in language. And yeah, so I really like looking at data qualitatively.
Got it. I think I had one like general question about like the team, you know. So do we need a software engineering team or department always, or can an application like this can be built inside a data science team? Just a data science team.
I don't want to I don't know. I don't want to overgeneralize maybe. And I know there are great data science teams, but what we are usually seeing is that they are a bit overwhelmed with the task of delivering a product. Because before the LLM hype, they delivered one-off analysis, maybe a model, but they still had a whole team deploying that, integrating that, and so on later on. And now the main task is not model building, it's product building. So I really like the combined team of like product engineers, software engineers who have worked closer to product, and data science to deliver something together.
Fantastic. All right. I think that was all the questions that we have. Unless someone has like a last minute question, I think we could take up one more. Waiting for 3, 2, 1. I guess not. So, all right. Thanks a lot, Mathis, for this session, and thank you so much for everyone for attending and for staying till the end, especially. So when we close this session, you'll see a small feedback form. It would be really nice for us if you could build that out. It's completely anonymous, so if you want to, tell us who you are along with the feedback, please do leave your email so that way we can get in touch with you. We'll definitely share the recording. So please look out for that in your email within the next few hours. I think it takes some time for the recording to reach us. But anyway, great session. Thank you so much, and have a wonderful rest of your day. Take care, Mathis.
Thank you. Take care. Bye.
Bye.